move up in like life. So what am I missing?
This is 10 over. Yeah.
Okay, that's pretty good.
Holy crap. To the nth power? That's the tightrope. So it's just 10 over n.
Oh my. It's like a 0. It's a degree.
That's good.
Rotate the goal 30 degrees. Let's take a look at these. Then we shall head out. Hey, early day.
That's
Early
nice.
day.
I need that.
Did go over, I was looking at the phone. I was looking at the phone 1 second, like the video just started, and then the next second,
On the what?
8 minutes, and then go. I'll start doing it before I
I feel like everyone's too long.
Val 2, brought to you by Guidance.
Yay!
Never mind, I'm gonna keep this.
I don't get why that projector.
Got your
always
enemies?
like stretched out on
No,
the
I
left
feel
side.
like a constant in there.
What's up? The projector's always stretched out on the left side. Oh.
You'll get it when you're older. I'll wait till you're nice and wise, and then I can tell you what.
Alright, guys, we have a chance to leave early. Let's all work together. Here we go. Here we go. This first guy. What's happening with this one? If you try to do absolute convergence, what do you get?
The harmonic series.
Which is a what?
Harmonic.
So it does not do what?
Converge.
Well, it does not do what?
Absolutely.
Absolutely converge. It might do what?
Conditional.
Conditional convergence. Okay, so I rule out absolute convergence. How do I check to see if this is conditionally convergent?
Alternating series test.
Alternating series. So real quick, why is alternating series good? What do I have to check? Or just say? Is the limit 0?
Yeah.
Yes. Check. So now I'm going to start letting you say, well, it's obvious. Right? So you still have to understand when it's obvious or not obvious. What else has to be true?
Decreasing?
Decreasing. Is that decreasing?
Yeah.
Check. Pretty obviously decreasing. What else? One more thing.
Oh, it's always.
It's positive.
Positive. 1 over 2n
Always.
for n greater than 0 is positive, correct?
Yeah.
Positive. Check. What does that mean?
It's
Convergent.
convergent.
Conditionally convergent. I love it. Conditionally convergent. Go over in here. Convergent.
Wait till you get to the next ones.
Okay. This guy is even better. So what do I check first? What do I rule out?
Absolute convergence.
Yeah, I look at the absolute value. Can somebody tell what this thing is going to be related to?
1 over n squared.
1 over n squared, p series, p greater than 1, so this,
Your cut.
okay. You gotta let me know, I don't use this thing a lot. Yes, so it absolutely converges. Do I have to worry about anything else?
Nope.
No, if it absolutely converges, it conditionally converges too, for sure. Okay, how we doing? Doing good. Real quick, is this sometimes negative?
Yes.
This
No.
negative side?
Oh, yeah.
Yes.
Yes. Is it sometimes 0?
Yeah.
Yeah.
No.
Wait.
It's 1 or -1.
Either 1 or
One
negative.
by pi.
It's either 1 or
Oh, yeah,
negative.
yeah,
Okay.
Yeah.
So I know if I make all the negative ones 1, it converges. So if I leave all the negative ones alone, it definitely converges. I don't have to do that. I know it's true. That's why you always do absolute convergence first. Because if that works, you're done. Okay. Obviously, you know what to try here. So what's it going to look like?
2n over n factorial.
Yeah.
That's the absolute value.
As long as it doesn't get washed out with my hands in there. Okay. So, this will be we limit, n goes infinity. Some of you guys, there's a few of you that did the same mistake. What's on top of the ratio test?
n plus one.
N plus one. So which one am I gonna put first? N plus one stuff first, right?
Yeah.
And then times the reciprocal of what they gave me, correct?
Yeah.
Without the negative one stuff, because I'm taking the absolute value. Okay. So it should be the n plus one stuff first, times the reciprocal of the original thing. Is that cool?
Is that even better than?
Totally. If you turn these around, you're turning around the original problem, which completely changes.
Oh, I get it.
If it converges or diverges, yes, okay. So what happens here, this is a nice one, yes? Maybe, so, I don't know, you guys are like, none of these are nice, what's wrong with it? How do I rewrite this? Is this cool, 2n times 2? You gotta let this become second nature. We all know this fact, right? Add powers when I multiply like bases. We just sort of forget it and we're not used to doing it backwards. So, no, it's a little freaky. What can I do on the bottom here?
N plus one times factorial.
Yeah, so then it matches with this guy.
Yeah.
And this matches with this guy. Da.
2 over n plus 1. That sounds nice.
Yeah, what's the limit as n goes to infinity of 2 over n plus 1?
0.
Which is?
Less
Plus
than
one.
1.
Which means?
Absolutely convergent.
Absolutely convergent. Like, absolutely. Okay.
Okay.
Totally. Totally. Alright, sorry.
Puka shell necklace.
Two does shell. I'm interested in the cookie shell alien from Halloween.
Pretty good.
I don't know if we can find a costume of some sort that's specific.
Big costumes.
Two to the
Alright, here we go.
2 to the third n.
plus 3.
Yeah, it'll be, and this is where people make all the mistakes in the world. They put 2 to the 3 n plus 1, that makes no sense. You're
No.
replacing n with n plus 1, 3 distributes,
We do that.
3 n plus 3 like you said, I like it.
Over.
Over.
7n plus 1.
7 to the n plus 1. And then times the reciprocal of the original.
So you can break
Alright,
that
now
up.
wait. Is everybody fine with what I've done so far on this problem?
Yes.
Yeah.
If you're not fine, there's at least 7 people around you that are also not fine, so it's okay if you ask. Okay. And now the next thing I've gotta do is just that weird backwards thing we're not used to. I can break these up.
2 to the 3n times 8.
Okay, 8, sure. 7 to the n times 7, right? So these die. These die.
So what's that? 8
A lot of death.
8 7.
8 7.
Oh well.
Yeah, I get 8 over 7. So that's 8 7.
Absolutely
Which is
divergent.
greater than 1. We saw it.
Absolutely divergent.
Divergence. We don't call it absolutely divergence. We say divergence. Alright. Now, what's really funny to me, we had a question about a homework problem earlier. This is basically that homework problem where I made K2. So if you really pay attention, I'm doing your homework for you right now. Or your help homework. So the weird thing about this is, it's got the 2 inside, it's got the square on the outside. They mean the same thing as always, right? We're just not used to factorials. But I would still do n plus 1 factorial all squared, right? Over, what's in here now?
2n plus 2 factor.
Good. Because I replace n with n plus 1, distribute the 2. Times the reciprocal of the original. Now something else you guys really aren't used to is, so if I had this, can't see it. I know. If I had this, what can you take out?
4.
All right, you're all like, let's do this, Jeff. If I had this, what can you take out?
4n.
4 to the 11th. What's here affects what I'm doing, right? So we're just not used to messing with that kind of thing much. So I have a square on the outside, whatever I do is effectively doubled in some way, right? Times itself. So, okay, let's see if you guys are cool. Well, inside here, there's multiple ways to do this. I can either write this twice, and and just deal with each piece, or would be a little bit better about that. Pull n plus 1 out, and then there's an n factorial, but I do this twice, and there's 2 of these. There's just 2 of each thing. Right? If I pull an n plus 1 out, doesn't it get squared? The same way the 4 I pulled out here gets raised to the 11th power, of course, right? Because there isn't 1 4, there's 11 4s. There's a 1 n plus 1, there's 2 n plus 1s. Maybe.
Mm-hmm.
All over, what do I do with this crazy thing? What did I say earlier about this?
2n plus 2 times 2n plus 1.
Yeah, I gotta take 2n plus 2, 2n plus 1,
Times 2.
and then I can finally stop, because now it matches up with this guy. So basically, this will tell me how many I've gotta pull off, most of the time. Gotta cover my ass there. Divided by n factorial squared. So look at all the shit that cancels, right? This cancels, this cancels, this cancels. Are the degrees the same on the top bottom?
No.
Yes.
Yes.
Isn't this squared? Isn't it squared? What would the leading coefficient here be?
4.
Up here it would be
1.
So it's 1/4, which
yeah.
is
Less than 1.
less than 1.
Absolute virgin.
Kind of virgin.
You like that YouTube
Who
channel?
did that?
Yeah, I saw it.
Weird. Don't watch
What's
Magic.
that about? You guys don't know that? So, finally. And fruit test. I love did you guys read my advice?
Yes.
Yeah.
So when everything is being raised to n power, it just wants the nth root test. So the nth root limit, n goes to infinity of the nth root of the absolute value, 10 over n to the n. Good lord. That's the limit, as n goes to infinity of what?
10 over
N
n.
over n.
N over n. And what do you get?
Zero.
Yes.
Less than 1.
Which is? Less than 1, which means it is?
Absolutely.
Absolutely convergent.
What?
The whole class here. Absolutely at the same time. Okay.
What?
Alright. This guy's a little bit more interesting. Just to remind you guys that there's a certain thing that can kind of show up anytime it wants to. Right? So nth root, because it's all to the nth power, it's screaming for a root test. So I give it to it. And I get this. Indeterminate form, right? Big L'Hopital's. And what do I get?
1 over n.
1 over n over 1. You eventually get 0, which is less than 1, which means it is
Absolutely.
convergent.
Alright guys, it's been a pleasure.
My dream is going. Alright, guys. Is that a wrap? By the way, 11-7, again, I've said this multiple times, but 11-7 is all the tests all at once from the whole chapter. So that's your 11-7 sure, and then 11-8 is where we're gonna start to work towards Taylor polynomials, which I'm really excited about. Which I don't know how that makes some of you guys feel, but okay. I need to know what that is. I understand.
It's the worst part of the series.
Oh man.
Are you posting the weather sign?
Yes.
Do we